Hello everyone, welcome to Microsam. In this tutorial video, we'll be learning about the tracking functionality to track objects over a series of time. Note for this video, it's expected that you're familiar with the installation and the Napari based annotation tool. Okay, so let's get started. Let's open the plugin, segment anything for microscopy and annotator tracking. There it opens the Napari GUI interface for us, and on the right is the tracking widget. Let's go ahead and open our sample image series data. There we go. Let's place the image series data layer at the end. Now let's go to the compute embedding widget. Let's go to the settings dropdown and load our pre-computed image embeddings. In this case, if we do it in the tool, this would take a few minutes. However, since we have pre-computed it, all we have to do is select the path and load the image embeddings. Okay, here we see that Microsam prompts us a validation message with the information of the model with which the embeddings were pre-computed. Okay, now let's get started with the annotation. Let's choose point prompts. Segment the current frame and start tracking this object over time. We see that with the default settings, the tracking feature might be quite tedious and often requires a lot of rectifications. We speed this part up in favor of a better tracking workflow. Let's remove these annotations and get started with playing with the projection mode. Over here we see the default projection mode is points. Let's choose single point as the projection method, which derives a single positive point prompt from the previously segmented masks. Let's go ahead and put a point prompt over here for segmenting this frame and segment all the consecutive frames. There we see that the segmentation quality has got much better for tracking the object. As we see over here that the projection across all frames did take place. However, we see that the segmentations for consecutive frames is a bit strict still. This can be altered using the IOU threshold parameter. The IOU threshold parameter decides the minimum overlap between segmentations for adjacent frames. The box extension is the factor by which the box prompts in the box projection method are increased to adjust with the object slices, and the motion smoothing is the factor used to follow the objects with a directed movement. To make the tracking feature a bit flexible, let's go ahead and reduce the IOU threshold parameter from the defaults. And let's start segmenting from the very first frame. Let's segment all frames. And there we see the object was tracked for more number of frames as we desire. We see some of these frames were missing. Let's go ahead and put positive point prompts and start segmenting all frames. Let's keep doing this until we get our desired tracked object. And there we see the first split of this object, where it splits to its daughter cells. Let's mark a division track in this mother cell by changing the track state from track to division. Let's go ahead and segment all frames with this division prompt. Now this frame marks the division of the current mother cell. Now let's go ahead and change back to track state and then choose a different track ID. And now let's start segmenting all the frames. We see that the split has taken place. Let's go ahead and track this daughter cell until the end of the frame. And there we see this daughter cell has been tracked until the last frame. Now let's go ahead and track the next daughter cell. Let's segment it on all the frames. And there we see it worked out for all the frames. Let's say we are confident about our tracked object. Let's go ahead and commit this. There we go. Now let's go in the first time frame and choose another object to track. Let's choose the object over here. Let's put a positive point, segment the current frame and segment across all the frames. We see that the object was tracked decently as we desire. Now let's remove the segmentation from the mother node that splits in the next frame. And let's mark this as the division frame by pasting a point prompt, changing the division track state, then segmenting all the frames, and there we go. Now let's go ahead and start tracking the daughter cells with a different track ID. Then let's segment all the frames. Now let's put another positive point prompt in a frame ahead in time where we still want to continue tracking the same object. Here, the previous frames in between the prompts will also be tracked with some segmentations. However, the segmentations might sometimes be incorrect, which can be easily rectified with the interactive annotations. There we see it was tracked. We see some of these frames were missed. Let's go ahead and track these as well. Some of these frames were still missed. Let's go ahead and track these. And there we go. The entire daughter cell has been segmented until the last frame. Now let's go ahead and track the second daughter cell with a different track ID and segmenting it along all frames. There we see the object wasn't tracked as far. Let's go ahead and put more point prompts. And there we see with one additional point prompt, the tracking was improved. We see a few more frames missing. Let's go ahead and track these as well. And there we go. We see the daughter cell and the mother cell were tracked. Now let's go ahead and commit the tracked object. We see the entire lineage was saved. Let's choose another object for tracking, which would be this one here. Let's go ahead and put a positive point prompt to start tracking. Let's segment in all the frames. And there we go. It has been tracked in all the frames. Let's rectify a few of these frames. And it has been tracked until the mother cell splits. Let's go ahead and remove the segmentations in the frame before it splits. Let's put a division track state and segment for all the frames, which would mark this frame to be the frame where it splits. Now next, let's start tracking the daughter cells with a different track ID. Let's go ahead and segment all frames. And there we see it's expected to put more point prompts for tracking the daughter cell. And there we see the tracking has improved. However, we do see some artifacts. Let's rectify them on the specific frames. And we see one of these objects has some artifacts. Let's put a negative point prompt and rectify them. And there we see this object was tracked until the last time frame. Now let's go ahead and track the other daughter cell with a different track ID. There we go. And we see that this expects more point prompts to track it better as well. We see that the object wasn't tracked in some of these frames. Let's go ahead and put positive point prompts to continue tracking. We see that the tracking has improved. However, for some of these frames, there were some incorrect segmentations. Let's go ahead and rectify them using negative and positive point prompts. There we go. Some of these frames might need additional rectification. Now let's say we are satisfied with our tracking over here. Let's go ahead and commit the current object. And there we go. Now in case the user wants to rectify some of these artifacts, we can do this using the erase tool. And there we go. All the artifacts which we desired to remove, we have easily removed them. The user has the choice to store the tracked objects and all the tracking data to a jar file via the commit path option. Now let's go to the committed objects layer, go to File, Save Selected Layers, and save the tracked objects in a TIFF file. This was the video for annotator tracking. For the next video on image series annotator, stay tuned. Thank you so much for watching.